This morning we're going to talk about taking our rational expressions and how to multiply and divide them. Again, we will pay special close attention to any restrictions that may be obtained, and we'll learn how to identify those as we go along. So to begin this process, we'd always start by factoring the numerator and denominators as usual. And then we also want to then multiply the fractions as we normally would. Top multiplies to the other top, bottom to the bottom. And in our case, really that means we can just run everything together. I encourage you to use parentheses to help isolate quantities so it doesn't become just a jumbled mess of terms. You have to remember what groups together and what doesn't. So let's look at number 4 to get us started. We want to multiply these two expressions to each other. Along the way, we will find the restrictions just like we did before. So we're going to start by factoring everything we see. So the first term, the first expression, is 3x squared and a negative 12. So if we break that apart, we're going to have 3, and then we're going to have x squared minus 4. Now, before I go any farther, I would like to realize that x squared minus 4 will break down again. That is a difference of squares. We will come back to that in a moment. The denominator of that expression has a greatest common factor of a 5 and an x minus 2. The second expression has a numerator of 1, and a greatest common factor on the denominator is a 2, x plus 2. Okay, so we're going to go back and we're going to finish cleaning up that difference of squares that still exists. So our numerator, excuse me, on the first one, just because I'm on a smart board, I'm just going to do it right on here. You would want to probably write a second line to this. This piece here is going to actually separate into x plus 2, x minus 2. Now, before I do any separation or anything like that, I want to multiply first, then identify my restrictions. So again, top times top. So I'm going to multiply that top, the numerator of our first, times the numerator of our second. Well, as we can tell, something times 1, it doesn't change. So when I put that all together, I'm going to start a new line here. We'll have this as our numerator. Okay. And then when we multiply the denominators, I don't want to refoil anything. Okay. I only want to combine things that easily combine. In this case, the 5 and the 2, they can become a 10. Anything in quantity form, I want to remain in quantity form. It makes it easier to identify what reduces. Okay. At this point, I want to find my restrictions. So in this case, remember, we're looking at denominators here. X cannot be plus or minus 2. So there's two restrictions. I'm just going to write it as plus minus 2. You can write them as individuals. X cannot be positive 2. X cannot be negative 2. That's fine also. Those are my restrictions. Now go through and simplify. This cancels with that. This cancels with that. So I'm left with a simplified expression of 3 over 10. This is my solution as a whole. 3/10 with the understanding that x cannot be plus or minus 2. So let's try that again. Look at number 5. A little bit larger, same process though. So they get more intimidating, but don't let them scare you. So I'm going to factor the first fraction in it itself. So I'm going to factor out an x, and I get x minus 2. The denominator on that guy will factor out to be a repeated root of a negative 1, right? So double factor of positive 1. The second part factors out. Like that. Okay? So I'm going to combine the numerator and denominator. Remember, when you multiply, they just end up running together. You could almost just take the little multiplication dot out from in between it if you wanted to and make it one giant fraction. In fact, let's just do that. Let's just pretend that guy's not there. They are now one giant fraction, right, with all these terms in it. And they're all being multiplied to each other. Let's do our restrictions. Restrictions have only to do with the denominator. So my x cannot be, let's see, cannot be -1, can't be a 0, and it can't be a -3. There's my restrictions. Okay, so let's go through and find out things that neutralize one another. Looks like we have a +3 and a +3. We've got an x here and an x here. We've got a +1 and a +1. Okay. So it looks like we're reduced. We end up having an x and a -2 over an x and a +1. This is our final solution. Our reduced expression and the 3 restrictions that come along with it. Number 2 and number 3, as you can kind of see on the screen, they just have like 6x squared. Remember, you can always just change that to be 6x squared over 1, right? I know it's kind of floating in between numerator and denominator. Technically, if it doesn't have a denominator, it has a denominator of a 1. So let's put that in there, okay? So that makes that easier to deal with. But they will happen just like this. So let's address some division. Okay, so division, if you remember, when you multiply or you divide a fraction, you technically multiply by the reciprocal, right? You multiply by it, you flip the second fraction, and you end up multiplying. We're going to do the same thing here. So the process is fairly simple. What we have to be cautious of, it changes our restrictions, okay? Our restrictions are going to be affected by the fact that we've flipped one of the fractions, okay? So what that means is the restriction will both be governed by the numerator and denominator of that second fraction. So let's take a look. Let's start by factoring, because that's always what we do. So let's do problem number 9, because it's got more factoring involved. Problem number 9 over here. So our first term, remember, is like all over 1, okay? So we're going to have, factor this out. We're going to have a plus 12, yeah, plus 12 and a minus 2, all over 1. Okay. We are dividing. We're going to factor the first one. That's a difference of squares. So a plus 12 and a minus 12. Okay. So here's where it's tricky. Remember, when we go to put these together, we need to reciprocate that green expression, right? We have to flip the second one. And so when we do restrictions, we're going to have to take restrictions from this denominator, and this numerator, because that numerator becomes a denominator when we reciprocate it. So looking at those 3 areas, we have restrictions that x will not be allowed to be a positive 12 or a negative 12. There's our restrictions, okay? Once we've done that, we are allowed to look at this like multiplication, but we must reciprocate that second term. So the first term will remain the same. We reciprocate and multiply the second term. So the denominator becomes the numerator. That will be all over 1, that blue 1, times the numerator, which is now the denominator of the second one. We've multiplied them together, so again, they kind of squeeze together and become one term. We've already gotten our restrictions. So we're going to find things that neutralize. And so what's left over is this. So our final reduced answer is 3 times the quantity x minus 2 with the restrictions that x cannot be a positive or negative 12. Okay? So again, the only tricky part is you must reciprocate that second fraction. And when you do that, that means both the numerator and denominator act as a denominator at some point in time. So we need to watch out for our restrictions. Let's try one, one more of those. Let's extend our screen here and do number 8. We're going to start by factoring our first one. Keep in mind, that's going to break down again, right? That is not factored as far as it can go, so you're going to end up breaking that down eventually. And the second one divided by plus 4 plus 2. Let's see, it looks like we're going to have 12 and 2. Nope. 6 and 4. There we go. Okay, so this is what we have. Keep in mind this x squared minus 4 is a difference of squares, so let's just go ahead and clean him up now. Everything else is fully broken down. So again, restrictions are going to be both denominators and the numerator of the second, because eventually that numerator becomes a denominator. So in our case, x cannot be a 0. It can't be a negative 6. It can't be a negative 4. It can't be a negative 2. And there's another negative 4 that's already been listed, so we're good. So we have 4 restrictions. So now we're going to reciprocate the second and multiply. So we reciprocate so that denominator becomes a numerator. And the numerator becomes a denominator. Now we find things that neutralize. We have an x plus 4. We have an x plus 2. And 5 and 25 reduced to a 1 and a 5. And so when we put it all back together, we will have a, let's see, we'll have x minus 2 and an x plus 6 in the numerator, and a 5x squared in the denominator. That becomes our final answer. And that is how you multiply and divide rational expressions.